Howdy, it's Tubal Cain again, and welcome back to part 7 of my build on the Stuart Progress engine. And we're kind of getting near the end, although I think there'll be a couple more parts yet. And before I get started here, let me just say that I had a visitor the other day, a young man by the name of Aidan Carnes, and he's from Metropolis, Illinois. You know, that's the home of Superman. If you ever go down to Metropolis, Illinois, and that's way in southern Illinois, there's a huge statue there and a museum and so on about covering Superman, so that's pretty interesting. And perhaps this young Aidan, he's only 13 years old, is a descendant of Superman, perhaps disguised as a young boy. Okay, and here's what Aidan made for me. This nice cutout here saying Mr. Pete 222 with a couple micrometers on. Look at the lathe up here. There's the chuck and the compound and the tailstock. Thank you, Aidan. That's pretty cool. You'll see that here in my shop from time to time. Now, in the last episode, I was drilling and then tapping these 6 holes here. So take your time when you do that so you don't break off a tap. And I sighed a little bit of relief when I finished that and did not break off a tap. So this being pretty much done, the next thing I want to do is start to make some of the bar stock parts, particularly the little pivot shaft here, which is pretty simple, but I'm going to make that in a minute. But first I want to take the 2 heads here and provide the clearance that I talked about earlier so that this little step does not block the steam port. I'm at the mill and I'm making the little clearance slot on the backside of the head in order for the steam to get in there. In other words, for the steam port. So that's an 1/8 inch end mill. And that's all there is to that, maybe a little bit deeper yet. Here's the little clearance slots that I made on the heads. Originally I was going to put them in at an angle, but I don't think there's any need, and this was easier. I've been working on this project for 9 or 10 days, and I would say that I have about 25 hours in it or more. I didn't work every day, and I didn't work 8-hour days. However, it probably takes about twice as long to do this while I'm videotaping than if I was just working alone, so to speak. I'm not working alone. There's thousands watching. Well, the next thing I'm going to do is make this pivot pin, and I've already taken the liberty of taking this 1/8 inch rod that was included and putting it on the lathe and putting about 5/16 of 540 thread. Now 540 thread again is 1/8 inch. Eventually I'll Loctite that in because you don't want that to spin loose as the engine is running. But it goes into the hole here, and this is the point at which you'll determine whether or not you drilled this hole square and drilled and tapped the hole in the cylinder good and square. Will it be a good fit? So looking at the spring that came with the kit, I'll put that on there, and there's a nut. I believe there's a nut. So I'll cut it off at the outer black line, throw that little piece away, and then I'm going to thread it 540 up to the other black line. Now, do not even think about using this type of die holder for making those threads, and this is a 540. But I have another one right here in this die holder, and I like to cut these threads on the lathe. It assures you a straight thread. If you use this, you'll be pouting all the way to the bank. You've seen me do this countless times. Be sure and use oil and chamfer the end of your work. And I'm in back gear, slow speed, and I'm going to watch that line. You have to really shove to get that die started, so I'm shoving on the tailstock. That's all there is to that. Now, since this lathe does not have a reverse, I take it out of back here and just spin it off. Now it's better to have a little extra thread here because I'm not really sure how tight I need to make that spring in order for it to run. Back to the bench. Now temporarily assembled, and this rod may be way too long and I probably should have put a little more thread on it, but I just don't know how much I'll have to take this up. There'll need to be a washer in there, and in fact they supplied 2 nuts, and I think they want to use one as, or I want to use one as a lock nut, in other words double nut it, if you will. But let me show you something here, and these are 540 nuts, but I'm wondering if they're I wonder if they're 1/8 inch Whitworth. I'm not sure what 1/8 inch Whitworth is, but they are not BA. But they're pretty little nuts, and you say, well, what's pretty about them? Compared to a modern day plated 540 nut that to me looks so out of place and out of proportion if that's what you would use. You see what I mean here, if I can get that on. There. You see what I mean? That isn't pretty. In some ways, that is pretty. You can make your own with small hex stock also. Now I will move on, and I'm going to start the piston rod, and then I'll have to make the piston also. Next I'm going to make the connecting rod end, and it's going to be made of 1/4 inch square brass, which was supplied. Now I changed the dimension of the piston rod from 1/8 to 5/32, but we'll have an 1/8 inch hole in there and an 8/32 thread on the end of it, and turn down just a little bit. And I intend to do that, and here's the piece already laid out with the cross hole, which will be drilled and reamed 1/8 inch. But I tell you what, I'm just going to drill it 1/8 inch because I want a little clearance. Sometimes the reaming, the reamed size is a little bit too tight, although I don't want it to be sloppy. And then I'm going to do this in a square collet. And you know what, here's one I've had for a couple years. I never have used it, never have opened it, but let's break it out. And this will be used on the Atlas lathe. This is a 3C collet. Square collets make the job so much easier than a 4-jaw chuck. So it'll go in there like that, but I think I'll drill, I've got some burrs on there. And it's so easy to drill that end hole and then tap it. I'll drill the cross hole right now off camera. I've already drilled the cross hole, as just mentioned, and now I'm ready to center drill and then drill and tap the end. But you know, I wasted 20 minutes cleaning up the horrible thread that was on the end of that collet that I showed you a few minutes ago. So any time that I might have saved by not using 4-jaw chuck was wasted. So anyway, maybe it'll work the next time I use it. And tapping it 8/32, including a bottoming tap. And now I'm turning down just a short section of it to remove the square corners. Well, there it is. I still need to saw it off on the red line and then face it, and you can see that the part with the X on it really is waste stock, but there were no real dimensions for this on the drawing, and that's true with a lot of these little parts. It just leaves a lot up to your imagination and creativity, so I don't really consider it a set of working drawings, but there's basically the end. Now it looks complicated, but there's just a lot of little operations on there, but the whole thing, if you don't have to repair a thread on your collet, only takes about 7 minutes. Next I will tackle the piston rod made of 5/32 brass, and I'll just thread the end 8/32, and then I don't know what the length is, so then I need to make the piston, so one step at a time here. But looking at it now as I start to assemble it, remember I talked earlier about I didn't know where to cut this off or how long this should be. Now it is becoming evident that I lay something in here. Well, what should I lay in there? This, perhaps, just an Allen wrench. You can see that I am off by approximately 1/4 of an inch. So I will have to remove material from those two spots that I just told you to move everything over. And that's going to be baguette and bagosh, but I think I'll wait until I get the piston made to do that. In the last few minutes I trimmed some off of this main casting, so you'll see that's a little bit shorter. Also this is a little bit shorter, and then I needed even more material removed, so I faced a little bit off the face of the crank, and now I am able to get the center of the piston rod in the center of the cylinder, and still have just a little bit of space in here. So there's just an awful lot of fitting involved when you're not working to exact dimensions on the parts, and that's all right when you have just a one of. Now the next thing I'm going to do is to tackle the piston that has not been made yet, as you can see, and I'm considering different materials. I was considering brass, and I was considering Delrin. Cast iron would be ideal too, but I don't think I want it to be steel. And if I look at the drawing, there's just very little information given, other than that's the piston right there. And the groove there, I believe, is for a packing. That is graphite packing. I'm not going to do that. I don't think that's necessary. So all I need is a piece of the brass that's 1/4 inch long, so it's a really small piston, and then that hole drilled and tapped in the center. And then if there's any material left, I would like to turn it on the pin here, the shaft, so that it's truly concentric, so I don't have any binding when I put it together. And this brass is just a little bit oversized. So let me get started on that. You know what, I changed my mind again. Instead of using 1/2 inch stock, I'm using 9/16 stock. I've turned it down to within 10 thousandths of the 500, that is, it's 510, I should have said. And center drilled it, sawed it off. And now what I'm going to do is put it back in the lathe. It's a little bit longer than 1/4 inch long. And I'll drill it and then tap it to 8/32, and then I'm going to mount it on this piston rod. And again, as I said before, turn it down to 499 thousandths, and I'll probably put a little oil groove right in the middle if I don't change my mind again within the next 3 minutes. The piston is mounted on that rod permanently, and I faced it off to 1/4 inch thick, and now I'm going to take it down, as I said before, to 0.499 thousandths, and then chamfer both corners. I'm doing this in an extremely accurate chuck. Otherwise you're assured of it being eccentric, and I want it to be concentric with the piston rod. So a collet is even better, but I did not have a 5/32 collet, so I got to settle for this little buck chuck, which is quite accurate. And then I'll polish it up a little bit and make sure that it fits into the cylinder before I take it out of the chuck. This is all taking quite a bit longer than what you might think, although I'm compressing it greatly in the video. I got a little bit of a crude ring there in the middle, and I got a real good fit within a 1/2 thousandth. I had to polish the shaft just a little bit because this shaft was oversized for a 5/32 reamed hole, and I've already had it together here. And make sure that you oil things as you assemble them. just a drop of oil. Oh, that was more than a drop. But it moves in and out freely, turns freely, no binding here or apparently in here. It should not be tight. You shouldn't be saying to yourself, oh well, I'll just run it in with 110 pounds of air and I'll put some lapping compound on there. No, you need to have a good fit now or remake the parts, as discouraging as it may seem. The next step is that this shaft is way too long. I have to determine the length and then thread it. I'll do that all off camera. I don't think that's very interesting, but that's a matter of baguesse and bagache, and this is way too long. You can do some measuring or just cut it and then remeasure. Do that several times, and then the final take-up can be just a little bit in the thread and then Loctite it. One thing I may not have mentioned before, I don't know, but did you notice that I drilled and tapped the holes where possible all the way through to avoid blind holes? And as unsightly as that might seem to you, remember there'll be a lagging over there when I'm done. I may have said that before. When I do something like this over 10 days, I forget what I might have said in the earlier ones without rewatching my own videos. You know, something just dawned on me as I was drinking a cup of coffee and taking a little break, is I cannot gloss over this particular step here because this is one that was hard learned by me and I wish I would have had someone to explain it to me. Now it might be obvious to some of you, but again here what I'm talking about is the length of the connecting rod here, or the piston rod. So let me show you how I'm going to do that, although this is a bit baguesse and bagache, but then again there's some method to my madness. But take a look now that I have the piston brought forward almost to the hole. And remember that there's still a bit of a step on here. So what I've done here is to mark the rod where I intend to cut it off and then put about a 1/4 inch or less of thread on there, because the thread in this piece here goes up to about the end of where the cylindrical part is. So I've got that marked red, and it took me a couple tries to get that marked to where I want it. Now watch what I do. I'm going to pull, or I should say I'll push the piston all the way back until it's touching the back plate here. I gotta rotate that just a little bit so you can see the line. Then bringing the crank all the way around like this, and then pushing it forward just a little bit so it's not actually touching the end of the plate there. You can see, so I think now I could measure with a depth micrometer in there, or depth gauge, but you can see that if that the red line coincides all about in the exact same spot. So now I feel that I am safe to saw off this and throw away this little end here and then put a thread right in here. Does that make sense to you? So that's my game plan, but I can't really show that to you. Well, I could, but that's pretty mediocre stuff to show you, but I think the important part here was to show you how I determined the length of that rod. What do you think of that? I still have a little interference where the pink paper is, so I'll take this crank off later and machine a little more off of that. And you know, it's got a terrible finish on it anyway. Sometimes I don't realize how bad a finish is until I get it on the large screen and magnify it, because I can't see that with my bare eyes. So, and that's of no consequence, but I'll do that off camera. You can see that was a tight fit. So it's rubbing there, but it'll still turn fine, and there's no other binding whatsoever. Just as smooth as a hound's tooth. A couple other things I'll do while I'm at it, and that is to put a flat on the shaft for this little grub screw, and do some other final fitting. And you know, I must be getting fairly close to the end, because I'm starting to think about paint, and you know how much I don't like to paint. So, but I am going to paint this. it'll be a rather superficial job. Then, remember I have gaskets to make, but probably the single hardest thing to do is coming up, and that is to locate and then drill the two steam passages. Because again, there's 4 holes to drill there. We got some holes that are right angled to each other and that have to have perfect alignment. So I'll talk about that a little bit later, how I'm going to do that. And there is more than one way to do that. Again, I've strayed quite a bit from the drawings because I don't think too much of this set of drawings. Another thing that I haven't done and may not do, I've talked about that before, I'm not going to do it. I've just made the decision. And that is the packing box that goes right here. I just don't see the need for it. As long as I got a real good fit and don't have much air or steam escaping here, there's no need for that, I don't believe, on a small scale engine like this. Alright, be back soon. Hello, it's a new morning and this is day 13 already of this build. So I made a few changes here off camera. Number one, I've changed a few measurements here such that you can see I now have plenty of clearance right in here. I was kind of fighting with that. And the other thing is, with this brass piston rod, I was having a problem. This had a little bend in it because it's so soft. When threading it, it just bent, and then it scuffs up in the chuck. So I switched to 5/32 drill rod, and my problems went away, and this is more accurately sized. The OD of the brass is not exact, but you can see that it's without a flywheel on there now. It's spinning quite nicely, and I made adjustments on the piston rod so that I have exactly the same amount on each end of the piston at the end of the stroke, which is 1/8 of an inch, or just a little bit less. Same thing here, only I can't show it, but I did do a dry run without the cover on there. So, up to this point, I'm quite satisfied. The flywheel is masked and ready to prime and then paint. That'll be painted green. I hope the color looks okay. And I have to get a can of spray paint, and I'm going to paint the base black. Alright, see you in a few more minutes. I'm making progress finally. I've got the base painted black, that's semi-gloss black, and semi-gloss green here, and everything else will be that color of green. So next thing I'm going to do, and I'll do most of this off camera, is to make my gaskets. I already punched a hole in the middle, and then you know how to make gaskets just by tapping. I think maybe those tiny holes will be a little bit of a challenge. I think they'll probably need to be punched rather than tapped. So I'll make those 2 gaskets, and then in the next video start talking about the little steam ports that I have to lay out and then drill. So that's enough for one day. This is Tubal-Cain saying so long for now, and I'll see you in the next part.